if we were looking at the specific graphs of each, an exponential graph has what type of asymptote? Has a horizontal asymptote where? At y equals 0, right? So we know that it's going to never cross the x-axis. And we know that its intercept will always be where? At 0, 1, unless it does some type of shifting up and down or right and left with our transformations. Okay, so this would be our function y is equal to b to the x power. Now, we know that inverse functions will always reflect over our identity parent graph, which is your y equals x. So let's go ahead and dot that in. So I guess I don't have to dot it in since I'm doing a different color. So here is our line y equals x, which we know things will reflect over. So if I had to reflect the point 0, 1 across the origin, or the line y equals x, not the origin, the line y equals x, what would it become on the other side? Reflecting over the line y equals x, we just flip the x and the y coordinates. So 0, 1 would become 1, 0 over here. And if my exponential graph has a horizontal asymptote at y equals 0, then the inverse would have a vertical asymptote at x equals 0. So my logarithmic graph is never going to cross the y-axis. So my purple is y is equal to log base b of x. Okay, so with no transformations, nothing funky happening, excuse me, to either of these, this is what your basic parent exponential graph would look like, and this is what your basic parent logarithmic graph would look like. Okay, and they're just inverses of each other. All right, so basic properties of logarithms. We're all very familiar with exponential properties, hopefully. So let's see if we remember all of our exponential properties. So if you had log with some base b, so what is the base of just the log button on your calculator? 10. So if it was something other than 10, some of your calculators do have a log base button. Peek at it, see if you can find it. I think if you hit the math button, I don't have mine on me. Is there like a log base option somewhere in there? Is it under the math? Yeah. Math and then A. And then depending on the software that your calculator has, it'll either pop up with like a little base block for you to plop it into and so forth. Okay, so basic rules. If you had log base b of 1 equals 0, well, b to the 0, anything to the 0 power is just always, 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 always going to be 1, right? So that's why if you had log base b of 1, it's going to be equal to 0. Do you guys remember how to convert from exponentials to logarithms? Do you remember that conversion? Maybe we should put a little star over here. So if you had, let's say, base bx is equal to y, if I'm an exponential, I'm running out of space. To go to logarithmic, you can just put yours right next to it. It would be log. My base of my power over there is b, so it becomes the base of my logarithm. And then whatever your output is over there becomes your input over here, so it would be y, right? Because inverses, you switch your input outputs. And then my output over on the left becomes my input on the left becomes my output on the right. So that's your conversion. So b to the 0 power is equal to 1. So for 2, b to the 1 would be equal to b, right? We convert it from log to exponential. Number 3, how would I convert that from log to exponential? It would be b to the y is equal to what? Log Oh, no, sorry, just by, thanks. So my logs would go away, which by equals by, right? So then y would have to equal y. And then for number 4, how would we do that conversion? It would be base b, so log base b x is equal to log, it's really tiny, base b x, which means x would have to equal x. Okay, so let's see if we can first evaluate these without a calculator, and then we'll go through and practice just to make sure we can evaluate with a calculator. Questions? Okay, so for example 1a, we need to think about my base of this log is a 2. So 2 to the third, oh, well, it's giving, never mind, we're not evaluating it. 2 to the third is equal to 8. On your calculator, can you put in a log base 2, 8? And we'll output as a 3. Go ahead and practice it. Make sure you can do it. So math, someone said it was A. We're getting it? We're good? Okay, so then for this one, 3 to the 1/2 power is equal to the square root of 3. Yep, that checks out. 5 to the negative 2 power is equal to 1 over 25. So that would be 1 over 5 squared, which is 1 over 25. 7 to the 1 is equal to 7. And then for this one, it would be base. So it would be a log, oops, I'm down here. Log, if we did our conversion, log base 6 of 11 is equal to log base 6 of 11. So pretty much the whole entire thing would cancel out to each other, and we would just have the 11s, right? So whenever you have a log, this is very tiny and my projector's bad, but whenever you have that log with the base of 6 and it has the same base down here as the power, and they just cancel out, and you're just going to be left with whatever is there. So if this was 5 log base 5, it would still be 11. If this was 4 log base 4, 11, it would still be 11. Okay, so they would cancel out from each other. Okay, so let's look how the actual functions themselves can be inverses of each other. So we have an exponential function for f of x, and then we have its inverse, which is the log. So if I wanted to evaluate f at negative 2, that would get me 1 over 2 squared, which is 4. F evaluated at negative 1 would be 1 over 2, so 1/2. F evaluated at 0 would be 2 to the 0, so 1. F evaluated at 1 would be 2 to the 1, which is 2. And then at 2 it would be 4. Okay, so now if I make these be my new x values, so 1/4, 1/2, 1, 2, 4, for the inverse, what should happen to all my outputs? They should go back to my original inputs, right? So log base 2, so log base 2 of 1/4 means I have to think 2 to what power gets me 1/4? Well, 2 to the negative 2 gets me 1/4. Log base 2 of 1/2 would get me 2 to what power is 1/2? Negative 1. 2 to what power is 1? 0. 2 to what power is 2? 1. 2 to what power is 4? 2. Okay, so now this is where we can see that they are inverses. So I have my input, I have my output. If I use that as my output as my input, I get back to the original as the output. Okay, so they are inverses. Yes, Maddie. Yes, that's why we have that intercept at 1, 0, right, and 0, 1. All right, so let's talk common bases. You guys already know the log button on your calculator has base 10. So if there is no base shown, it is safe to assume that it is base 10. So for A, if my base is 10, 10 to what power gets us 100? So what would be log 100? 2. So log of 100 would be 2. For B, 10 to what power gets me to 10 to the 1/2? What does X need to be? 1/2, right? So we would just have log of the square root of 10 would get us to 1/2. For C, 10 to what power gets us 1 over 1,000? Well, 1 over 1,000 is the same as 10 to the -3. So what does X need to be to get to -3? -3. And then what would be log 6 to the 6? So 6 to what power is 6? 1. So that whole entire thing just becomes 1. So 10 to the 1 is 10. Which we all could get those using our calculators very easily, right? Hopefully, because you have log buttons on your calculators. All right, so now let's do ones that aren't so nice. Log of 34.5. Type it in. What do we get? 34.5. Let's go 4 decimal places. 1.5378. Log of 0.43. -0.3665. Log of -3. Uh-oh. Why is it undefined? Because it's negative. And what do we know about the domain of our log? Our log cannot pass the y-axis, so it can't be negative. So our domain has to be from what to what? 0 to infinity. It will never equal 0, so keep parentheses around it. Okay. All right, so now solving basic log equations. Almost there. All right, so we're going to do our conversion. Here we have a base of what on the log x? 10. So 10 to the third is going to be equal to x. 10 to the third is 1,000. Right? Yeah. So x is equal to 1,000. For B, my base is 2, so 2 to the 5th is equal to x. Is that 32? So we get 32. So when we started with an exponential, we converted it to log. We're starting from a log, we want to convert it to exponential. And then the same thing with e's. Natural logs of e's are just going to cancel out with each other. So the natural log of e square root it is the same as the natural log of e to the 1/2. So what would happen when we take the natural log of e? We practice this on your worksheet, or maybe you didn't get to the back. They're just going to cancel, so the whole thing's just going to be 1/2. Because the natural log of e is just 1. What's b going to be? 5. And then c would be 4. And then hopefully we can do calculator work. Natural log of 23.5. I'm getting 3.1570. Natural log of 0.48 gets us negative 0.733, 39640. And then any guesses what's going to happen with C? It's going to be undefined again because it's still a logarithm, because our domain can't be negative and it can't be 0. So let's quickly get our basic properties. Natural log of 1 is 0 because anything to the 0 power is 1. Natural log of e is 1 because e to the 1 is equal to e to the 1. Natural log of e to the y is equal to y because e to the y is equal to e to the y. So it would have to end up getting you to the y. And then same thing with number 4. It would be base e, so natural log. Do we want to write it in? I'm thinking if I want to put it in logs. So log, let's just put natural log. So the natural log of e to the, all right, now I'm confusing myself. This is what I wanted to do. Log of base e to the x is equal to the natural log of x. And we know that log with a base e is the natural log of x. That's what my mind was thinking. So then x would have to equal x. Okay, almost there. Graphing. Transformations. What's going to happen to my parent graph if I have an x plus 2? It's going to move left or right? Which way? Left 2. Good. So that means my vertical asymptote is no longer at x equals 0. It's now going to be at x equals -2. And my point of 1, 0 is now going to move to where? If it's going left 2, it'll be at -1, 0. And just kind of make your curve. Ooh, B, that's a fun one. What do we have going on there? So remember, that's the same as the natural log of -x plus 3. So what does that negative in front of the x do? It's going to reflect it where? Over the x or the y? Over the y. And then, if we remember correctly, with these, when we had to get our right-left movement, I have to factor out that negative, which means I would be moving to the right. So then we would move right 3 units, just to figure out that right-left transformation. So if I reflect my vertical asymptote over the y, it is unchanged. But now we're going to move it to the right 1, 2, 3 units. So now my vertical asymptote is going to be at x equals 3. 1, 2, 3. And then my point would be where? 4. So if I had it at 1 and I reflected it over the y, it would put me over here at -1, 0. But then I have to shift it to the right 3, so 1, 2, 3. So now it's going to put me at 2, 0. And then there's our graph. And then the last 2. What's happening in C? Is it shifting right, left anywhere? Nope, we just have a vertical stretch by 3. So the only thing that's going to happen there is it's just going to be steeper. Maybe we could get other ordered pairs to make it a little bit better, but we'll stick with that for now. And then for D, what's happening to our graph? It's going up 1. So my vertical asymptote is still unchanged, but now 1, 0 is going to move to 1, 1. And then we'll have something that looks like this. Any questions? Yeah, so it's just going to have the same intercept at 1, 0. It'll just look the same. It's just that you would have other points over here that aren't going to be a little bit different. So if we had to analyze it, what would be the domain? 0 to infinity. My range is all real numbers. Is it continuous? Yes. Is there symmetry? No symmetry. Is it bounded? No, unbounded. What else can we use for analyzing things? Let's talk about the end behavior on the right. So what's the limit as x approaches infinity? It's getting infinity, it's going to keep getting larger up to infinity, right? As f of x approaches 0 from the right, it's heading towards negative infinity. Are there any extremas? No extremes, no max or mins. So no extrema. Extrema, I have a x-intercept at 1, 0. No, I think that's good. Okay, so my gift to you is we'll eliminate homework. So have no homework for the weekend.